Hello students, welcome to Anne's classes. Let's do natural numbers and whole numbers exercise 3b. This is on page number 33. Question 1. Consider two whole numbers a and b such that a is greater than b. Okay, so we're going to take two whole numbers a and b, and a is greater than b. Now we have to answer a few questions. Is a minus b a whole number? The second part of this, is this result always true? So let's look into these questions now. So let's consider a to be equal to say 7 and b to be equal to 5, because the question says a is greater than b, isn't it? Now let's answer this question. A minus b, is that a whole number? So let's do a minus b. So a now minus b. A minus b will be 7 minus 5. And how much is 7 minus 5? 7 minus 5 is 2. So the question is a minus b a whole number? 7 minus 5 is 2 and 2 is a whole number. So the answer is yes. Now let's take one more example to prove this. Now let's take a to be, remember they are whole numbers and a is greater. So let's take a to be 10 and b will make it say 7. Okay, so now a minus b. So we are going to do a minus b. That is 10 minus 7. How much is 10 minus 7? 3. Now let's answer this question here. The question here, is a minus b a whole number? Is a minus b, that is 10 minus 7, 3 a whole number? Yes, it is a whole number. And is this result always true? Yes, this result is always true. And we have seen it in two examples here. So that is our answer here. So the question is a minus b a whole number? This is a question that has been asked of us, and our answer is yes. Is this result always true? Yes, it's always true. Now the next question, is b minus a whole number? Is this result always true? So here also we're going to see now the reverse, is b minus a whole number? So now let's take the same things. A is equal to 7, the same example that we took for the first one, and b is equal to 5. Now this is b minus a, that is 5. So let's write b minus a. So is b minus a whole number? So let's see, b is 5 minus a is 7. Now here the signs are different, isn't it? 5 has a plus sign and 7 has a minus sign. When signs are different, we put the sign of the bigger number and we subtract 7 minus 5, 2. So what have we got now? We've got minus 2, and minus 2 is not a whole number. Here we've been asked, is it a whole number? And we can see minus 2. Minus 2 is not a whole number. Let's take another example. So here we'll take a is equal to 1 and b is equal to 0. So this will be b minus a, and b is 0, and a is 1, but we're going to say minus here. 0 minus 1 will be minus 1, and minus 1 is not a whole number. So here we can see that when you do b minus a, the answer is not a whole number. And is this result always true? Yes, it's always true, isn't it? Every time you see that it's not a whole number. So let's answer our questions. Is b minus a whole number? No. Is this result always true? Yes, it's always true. Question 2. Fill in the blanks. 8 minus 0. 8 minus 0 is 8. Now 0 minus 8 is minus 8. Okay, so that we got it right. Now 8 minus 0, that is this 8 minus 0 is not equal to 0 minus 8. We just found out, isn't it? Because one answers 8, the other answers minus 8. So this statement 8 minus 0 is not equal to 0 minus 8. This shows subtraction of whole numbers is not, we're talking about a property, and that property is called the commutative property. Okay, so that is commutative property. And what is the commutative property? This is true for addition of whole numbers, but not for subtraction of whole numbers. That is, when you change the order and subtract, the answers are different. 8 minus 0, when we change the order and put 0 minus 8, the two answers are different. That means subtraction of whole numbers is not commutative, whereas addition is commutative. If you write 8 plus 0 is 8, 0 plus 8 is also 8. So for addition, it is commutative, whereas subtraction of whole numbers is not commutative. Question 2. 5 minus 10. Now, here signs are different, isn't it? So we put the sign of the bigger number and we subtract 10 minus 5 is 5. So the answer is minus 5. And the other part of the blank sentence says, which is not a. Now, minus 5 is not a whole number, isn't it? Because it has the minus sign. Minus 5 is not a whole number. Now, let's continue. This means subtraction of whole numbers. Subtraction of whole numbers is not closed. That means we are talking about a closure property. What does the closure property say? Now, this is true for addition, but not for subtraction. In addition, you saw that when you add up two whole numbers, your answer is also a whole number. Whereas in subtraction, as we saw in this example, when you subtract two numbers, you don't always get a whole number, isn't it? Now, if you say 10 minus 5, you'll get 5, which is a whole number. But when we said 5 minus 10, we got minus 5, which is not a whole number. So subtraction of whole numbers is not closed. So the closure property is not applicable to subtraction of whole numbers. Question 3, 7 minus 18. Now let's do the subtraction and see. 7 minus 18. Now this has a plus sign. So signs are different here. So when signs are different, we put the sign of the bigger number and we subtract. So here we subtract 18 minus 7. Let's do that. 18 minus 7. 8 minus 7 is 1 and 1. So here we get 11. So 7 minus 18 is minus 11. So let's write the answer here, minus 11. Now the second part is 7 minus 18 within brackets minus 5. So the difference of 7 minus 18 should be taken first. And that we already got 7 minus 18, we got minus 11. So we can write the same thing here. So let's write minus 11 and minus 5. So when signs are the same, we put the same sign and we add 11 plus 5 is 16. So our answer here is minus 16. Now, the other part here is 18 minus 5. How much is 18 minus 5? When you subtract 18 minus 5, you get 13. And 7 minus 18 minus 5. So let's do that. 7 minus, now let's work out these two. 18 minus 5 is 3, isn't it? 13. 18 minus 5 is 13. Now let's open the brackets. 7, and this is a plus sign. But when you see a minus sign before the bracket, you change the sign of plus 13 to minus 13. So here what do we have? 7 and 13. This has a plus sign. So we put the sign of the bigger number and we subtract 13 minus 7. 13 minus 7 is 6. So here we've got minus 6. So here we've got our answers. 18 minus 5 is 13 and 7 minus 18 minus 5 is minus 6. Now, the question now says 7 minus 18 minus 5, that is this one, 7 minus 18 minus 5 equal to 7 minus 18 minus 5, that is this. So they're asking us, is minus 16, that's the answer we got for the first part, equal to the answer to the second part, which is minus 6. Are they equal? They are not equal. So the answer to this is no. These two are not equal. Question 3. Write the identity number if possible for subtraction of whole numbers. So let me explain this with the help of an example. So let me do it for addition first. Now when a number is added to 0, now 3 plus 0 will give us back the same number, isn't it? Similarly, if I say 0 plus 3, we get back 3. So the number like 0, when it is added to a number, if it gives back that same number, then this 0 is called the identity number. So it can be 0 or 1. Now 1, you cannot have 1 here because the number will change. If I say 3 plus 1, it will become 4. It will not remain as 3. If it remains as 3, then that number is called the identity number. Now this is how it is for addition. So for addition, 0 is the identity number or the identity element. Now let's see the same thing for subtraction. Now suppose I say 3 minus 0, I get 3. Now suppose I say 0 minus 3, I get minus 3 and not 3. So here can you see the number has changed. This 3, when I say 3 minus 0 has remained the same, but this 3 has now become minus 3. So 0 is not the identity number for subtraction of whole numbers. It is the identity number of addition of whole numbers, but not subtraction because the number has changed. So in a subtraction, we say that for subtraction of whole numbers, no identity element exists. Question 4. Fill in the blanks. 12 into 9 minus 6. Since we have brackets here, we have to work out brackets first. 9 minus 6 is 3. So this is going to be 12 into 3. Let's write that. So 12 into 3. 12 threes are 36. So this is our answer for these blanks. Next one. 12 into 9 minus 12 into 6. So let's do this. 12 into 9. 12 into 9. 9 twos are 18, carry 1. 9 ones are 9 plus 1, 10. So here we have 108 minus, now we have to multiply 12 into 6. 12 sixes are, we know, is 72. Now subtract the two answers. 108 minus 72. So let's subtract these two and see what we get. 8 minus 2 is 6. Now here we need to borrow. So 10 minus 7 is 3. So here also we've got 36. Now let's answer this. Is 12 into 9 minus 6, that is this first portion, 12 into 9 minus 6 equal to 12 into 9 minus 12 into 6. Now when we multiplied this, we got the answer 36. When we multiplied this, we got the answer 36 again. So these two are equal. That means our answer to this question is yes. Is this type of result always true? Yes, it is always true because here we have followed the distributive property. So this answer is also yes. Let's go on to the next one. Question 5, fill in the blanks. First one, 16 minus 8 into 24. So the first part, since we have brackets here, we have to do 16 minus 8. And what do we get? 16 minus 8 is 8 into 24. So let's write that 8 into 24. Now let's multiply 8 into 24 or 24 into 8 and see what we get. 8 fours are 32, carry 3. 8 twos are 16, 17, 18, 19. 192. So 8 into 24 is equal to 192. Now 16 into 24 minus 8 into 24. So first let's multiply 16 into 24 and see what we get. So 16 into 24. 4 sixes are 24, carry 2. 4 ones are 4, 5, 6. Second step, 2 6 are 12, carry 1. 2 ones are 2 plus 1 is 3. So 4, 8 and 3. 384. So that is 384 minus, now we have to multiply 8 into 24. And we've already done that here. 24 into 8 is 192. So let's write that 192. Now we have to minus these two. So 384 minus 192. 4 minus 2 is 2. Now 8 minus 9 we can't do, so we borrow. 18 minus 9 is 9. 2 minus 1 is 1. We've got 192. So we've got 384 minus 192 equals 192. Now the question is 16 minus 8 into 24, that is this. 16 minus 8 into 24, is that equal to 16 into 24 minus 8 into 24, this one. So they're asking us, is the first part equal to the second part? The first part we got 192, second part also we got 192. So this statement is true. It is equal, yes. And is this type of result always true? Yes, this is true because we have followed the distributive property. Find the difference between the largest number of 4 digits, and the smallest number of 6 digits. So let's begin. The largest 4-digit number is, now let's write down, which is the largest 4-digit number? 9,999. This is the largest 4-digit number. Then the smallest 6-digit number. Which is the smallest 6-digit number? Remember, it is 6 digits, so 1 followed by 5 zeros. 1, 2, 3, 4, 5. Now we have been asked to find the difference. Difference means subtracting these two numbers. So let's find the difference between these two numbers by subtracting them. So that means we have to subtract. Now this is 1 lakh. So that is 1 lakh, 1 followed by 5 zeros, minus 9,999. So let's do that subtraction. Minus 9,999. Put it in the right places. Okay, so now we're going to do the subtraction. Let's start. Now since it's all zeros, we're going to borrow from here. So this is 10, 9, 10, 9, again 10, 9, 10, 9 and 10 here. So now let's do 10 minus 9 is 1 and then 9 minus 9 0, 0, 0 and here we have 9. So what do we have here? 90,001. The difference is 90,001. So this is our answer. Question 7. Find the difference between the smallest number of 8 digits and the largest number of 5 digits. So the smallest 8-digit number is, remember 8 digits will be, smallest will be 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now place your commas to read the number. Ones, tens, hundreds, thousands, 10,000s, lakh, 10 lakhs. So now your answer is 1 crore. This is 1 crore, which is the smallest 8-digit number. Now we have to write the largest 5-digit number, which is the largest 5-digit number will have 5 nines, 99,999. Now to find the difference, we have to subtract the two, that is 1 crore minus 99,999. So let's do that subtraction here. So we have 1 crore, 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7 minus 99,000. Put it in the right places. 99,999. Now let's subtract these two numbers. Let's borrow. So 10, 9. Then again we have 9. Since we are going to borrow, all these become 9. The last one remains as 10. 10 minus 9 is 1. Then we have 0, 0, 0, 0. Then we have 9 and 9 here. Now place the commas and what do you get? 99 lakh 1. 99 lakh and 1. So what is the difference? The difference is 99 lakh 1. This is our final answer. So with this, children, we come to the end of this exercise. Thank you, children.